This is the first part on a series on greenhouse gases other than carbon dioxide. Interestingly, each group has its own story. We're going to start with fluorinated gases, otherwise known as ozone-depleting substances. Who here remembers the ozone hole? Sheep in Australia going blind? If something wasn't done about it, we were all going to die of skin cancer. The hole was big and getting bigger every year. And then in the 90s, it stopped being news. For people under 30, they may not know anything about the ozone hole. Actually, the hole is still there. It just isn't growing. And we know it's going to start shrinking and should pretty much be gone by around the middle of this century. That's because of some Nobel Prize-winning science, world-class chemical engineering, and the best environmental treaty in Earth's history. And because of this treaty, we are actually doing something about the most powerful greenhouse gases known to man. I mean, these things are nasty. If we were to design something to warm the planet, these are the molecules we'd be producing and releasing into the atmosphere. There are a lot of acronyms that I'm going to toss out. Every one of them is defined, but I thought a table of them and the gases that I'll be discussing would be helpful. For those of you who use YouTube chapters, you can use that to get back here under the chapter Tables. We'll revisit the table of gases towards the end. Let's start with the ozone layer, what it is and why it's important. Ozone is just an oxygen molecule, but with 3 oxygen atoms rather than the standard 2. At ground level, it makes up a component of smog and is pollution. But in the upper atmosphere, it blocks the natural ultraviolet radiation from the sun. Without these ozone molecules in the stratosphere, the UV radiation could reach the surface of the Earth, leading to skin cancer and cataracts. Scientists figured out that a class of molecules known as chlorofluorocarbons, or CFCs, destroy ozone. This was problematic because these molecules were commonly used in fire extinguishers, as propellants in spray cans, and refrigerants, which are the working fluids in air conditioners, heat pumps, and refrigerators. Chemical engineers liked CFCs because they're incredibly stable, which is great for refrigerators, but not so great for the environment because once they escaped into the atmosphere, they could last there for over a century. In 1985, the hole in the ozone layer was detected above Antarctica, confirming the theory that CFCs were a problem. And just 2 years later, the Montreal Protocol on substances that deplete the ozone layer was signed to reduce and eventually eliminate CFCs and other ozone-depleting substances, or ODSs. The treaty requires rich countries to eliminate ODSs faster than poor countries, which means that they would fund the creation of new chemicals that would not destroy the ozone layer. Everyone is assisted by the Ozone Secretariat, which is based at the UN Environment Program in Nairobi, Kenya. Chemical engineers got working and created hydrofluorocarbons, or HFCs, which can replace CFCs and do not destroy the ozone layer. The treaty worked as designed, and slowly but surely CFCs were replaced by HFCs, and the ozone hole stopped growing. The improvements come slowly because CFCs are so stable, but it's expected that by around 2060, the ozone hole will be effectively gone. But while HFCs solve the ozone problem, they are very effective in blocking infrared radiation, making them powerful greenhouse gases. The metric we use to describe how bad a kilogram of a chemical is for the climate is its global warming potential, or GWP. By definition, carbon dioxide has a GWP of 1. Some of the HFCs had a GWP of over 1,000. Luckily, there's much less of it in the atmosphere than carbon dioxide, but since they last for over a century, the sooner we stop producing them, the better. So in 2016, the Kigali Amendment to the Montreal Protocol was signed. This amendment requires that replacements for ODSs also be climate friendly. One of the possible replacements for HFCs as a refrigerant is carbon dioxide. Obviously, carbon dioxide is a greenhouse gas, but so much less effective than the HFCs that it's a big improvement. Another class of chemicals that may be used, I'm not even going to try to pronounce it, or HFOs. They don't deplete the ozone layer at all and have about 1/1000th of the greenhouse warming potential of HFCs, similar to carbon dioxide. So let's look at that table of gases again. You might have noticed that they're ordered by environmental harm, from CFCs to HFCs to HFOs and CO2. The global warming potential and lifetime values are a little complicated because other than CO2, these are all classes of chemicals with varying properties. But the key takeaway is that the CFCs that were being used before the Montreal Protocol were just all around horrible. The HFCs were much better for the ozone layer, but were still powerful greenhouse gases. And the HFOs and CO2 are both relatively benign. And the Montreal Protocol and its amendments, especially the one from Kigali, have been able to respond to the best available science at the time to protect our environment. While the Kigali Amendment is successfully transitioning us off of ODMs to refrigerants that aren't greenhouse gases, it doesn't have anything to say about how we manage the CFCs and the HFCs that have been produced or will be produced. One of the project drawdown elements is refrigerant management, managing leaks and disposal of CFCs and HFCs rather than letting these chemicals escape into the atmosphere. Under U.S. law, it's illegal to intentionally vent any ODSs or ODS substitutes into the atmosphere. And there are safe disposal requirements for appliances to ensure the removal of the refrigerants. Once the refrigerant is removed from the appliance, it can either be destroyed or recycled. There's a strong market for recycled CFCs and HFCs since the equipment needs to be modified to run on HFOs or other non-harmful refrigerants. So we're doing okay on keeping the ODSs out of the atmosphere, but the focus is really to move beyond using all of these harmful chemicals. When it seems like big meetings like the one we recently had in Dubai are exercises in hypocrisy and excuse-making, think back to a relatively quiet and obscure meeting in Kigali, Rwanda in 2016, when the signers of the Montreal Protocol on substances that deplete the ozone layer gathered to make sure that the chemicals that were replacing the ozone-depleting molecules were also better for the climate. This alone won't solve the problem, but it has shown that progress is possible, and it often happens away from the limelight. Since you made it to the end, I'm guessing you learned something from this video, so please like and subscribe. The like helps the YouTube algorithm know that this is a video they should show to others. If you want to support this channel financially, you can buy me a coffee. The link is below and to the right next to me. You can watch another one of my videos here, and please share this video with anyone you know who can remember cans of hairspray filled with ozone-depleting, climate-wrecking CFCs.